Okay, everybody, welcome to video 4 here. We're going to talk about relative frequency and conditional frequency. So if you'll recall, relative frequency is just the part over the whole. It's similar to probability, but not exactly because the probability is all just based on the likelihood of something happening, whereas when we talk about the relative frequency, it's the ratio of times the specific event occurred divided by the total. So there's that distinction between the two. Let's look at an exercise. So we're going to consider the data about high school's after-school activities and calculate the relative frequencies for each cell as a percent. So what is the relative frequency of a student who indicated they played basketball? So when we look at this chart here, which is missing on yours, so just look at mine, we have the students, all students who indicated they played basketball. So now we're looking at basketball, so played intramural basketball. There's no distinction between male or female. So this is talking about 40 altogether out of the 100. So the relative frequency for that would be 40% because they said we had to write it as a percent. What is the relative frequency of males who play basketball? So what's the distinction here? Here we're not just looking at all the students, we're looking specifically at the males. So relative frequency relative to the total, so it's still going to be out of 100. So then I need to look up at the chart and ask myself, okay, well, how many males said that they played basketball? So males, it's 20. So 20 out of the 100, 20 males. So that would be 20%. Okay, now take your time to go ahead and fill in all the relative frequencies down below. It's just like what we've done here, only you're going to fill in each of the cells. Try first to see if yours match mine. Pause the video to give yourself enough time to give this a try. Okay, so for each of these, they're all out of 100 because they're relative frequencies. So they're represented out of the total. So the number of males that played intramural basketball was 20 out of that 100, which made it 20%. The number of males who played chess was 2. 2 out of 100 is 2%. And then males played in the jazz band was 8, so 8 out of 100, 8%. Who did not participate, males who did not participate was 10. 10 out of 100 is about 10%. And then the total males was 40. 40 out of 100 is 40%. Same idea for the females, so all of these numbers, so the 20 out of the total 100 is 20%. 10 out of 100 is 10%. Again, 10 out of 100 is 10%. 20, so 20 out of 100 is 20%. 60 out of 100 is 60%. Then all the totals, so the totals that played basketball was 40. 40 out of 100 is 40%. The totals that played chess was 12. 12 out of 100 is 12%. The total that played in the jazz band was 18, so 18 out of 100, 18%. And then total that did not participate was 30. 30 out of 100 is 30%. And the total was 100. 100 out of 100 is 100%, which this is always going to be your 100% because it's always your total. So that's 100%. Okay, now we're going to use these to answer some follow-up questions. Okay, so if a student were randomly selected from the students at the school, do you think the student selected would be a male or a female, and why? Well, to answer this question, we need to look at the relative frequencies for males and females. If I look up here, the males is 40%, the females represent 60%. So if a student were randomly selected, I would expect them to be a female. And I just wrote females because the relative frequency is larger for females than males. Next question, if a student were selected at random from school, do you think this student would be involved in an after-school program, and explain why? So that would mean I need to look at the ones that do not participate and try to find out if that's a bigger percent than the number that does participate. So if I look up here at the ones that do not participate, it's only 30%. So 30% of the school do not participate. That means the rest do. So I just wrote that out as yes, because the relative frequency for those that do not participate is 30%, meaning more participate. The next question says, why might females think they are more involved in after-school activities than the males? Explain your answer, and is this a logical conclusion? Well, I think that if we look at the numbers for females, the 20% and 10% and 10% and 20%, and 60% altogether, those are all higher or the same as the males, which are at 20%, 2%, 8%, 10%, and 40%. So they might think that they are more involved. I just wrote that as females might think they are more involved because their relative frequency is higher. However, this is not a logical conclusion because if we think about the number of people surveyed, there were more females. So it's not a fair sample in the beginning. And since there are more females in the study, it makes sense that their relative frequency is higher. So I just wrote that as because more females were in the sample, the end part there. We would like to understand associations or trends within the data set. For example, would a response to one category tell us something about the response to the other category? So in this exercise, we're going to look at a class of 20 students recording their hair color and eye color shown in the two-way frequency table below. How many students have blonde hair and blue eyes? So blonde hair and blue eyes, that is a joint frequency between those two, blonde hair and blue eyes. So I'm going to look over here at blonde and blue eyes and go where they meet together. So blonde and blue eyes meet together right here. So this is the number here, 4. 4 students meet that. How many students had red hair? Well, now we're just looking at students with red hair. There is no other information or category to make a joint frequency out of. So instead, I'm just looking at red hair. So that means I'm looking at the marginal or the total. So the total for the red hair, the marginal frequency here is 4. So again, 4 students. Now, is there a connection between eye color and hair color? Justify your reasoning by doing a conditional relative frequencies. So conditional relative frequency, what is this? Well, this compares a frequency count to the marginal total that represents the condition of interest or the condition that we are looking at. So let's look at an example. What is the conditional relative frequency of having green eyes if you have red hair? So what is the relative frequency of having green eyes if you have red hair? So which one is given? We know that they have red hair. We're looking for the conditional relative frequency of then having green eyes. So we're only looking at those with red hair. So of those, how many have green eyes? So then I need to look at green eyes. So it's 3 out of the 4. So that is 3 out of the 4, which equals 0.75, which is 75%. So the conditional relative frequency would be 75%. Okay, so the next one. What is the conditional relative frequency of having green eyes if you have black hair? So which one is given? It's given that we have black hair. So we're only looking at the people that have black hair. So I highlighted that. We're only looking at the given condition, having black hair. What is the conditional relative frequency of then having green eyes? Well, we need to look at the green eyes. That would be 1 out of the 9. So the conditional relative frequency, we could leave as 1/9. The equivalent decimal is 0.1 repeating. So if we're going to change it to a percent, it's an approximate. So approximately 11%. Okay, the next question. Does it appear that having green eyes has a dependency or at least an association with having red hair? And explain. So if we look at the one where we talked about having green eyes and red hair, there was 3/4 of the people that fell into that category, or 75%. Now, if we compare that and we look at how many then did not have the green eyes, it was 25% that did not, the 1 and 0, which is just 1 out of the 4. So I wrote that out as, yes, there appears to be an association between having green eyes and red hair because the conditional relative frequency is much higher at 75% compared to having blue eyes, which is 25%. Okay, the last question says, is it more likely that a person with black hair has blue eyes or that a person with blonde hair has brown eyes? Use conditional marginal frequencies to support your answer. So we have 2 situations we need to look at here. In each situation, the hardest thing about conditional relative frequency is finding out what condition is given. Which one are we looking at for the total and then the part out of it. So the first one, is it more likely that a person with black hair has blue eyes. So which condition is given? Person with black hair. So that part with black hair means I'm only looking at the black hair column. So what's the total if I go back up to my chart with black hair? So if I look back up here and I say with black hair, so I'm only looking at this green column, these 9 people. So of those 9 people, how many have blue eyes? That's 3. So the 3 out of the 9 is the fraction for that. So to keep my thinking straight, I wrote the black hair, blue eyes title because that was what we're looking at this first part here. With person with black hair has blue eyes. So that's the one I'm writing in blue. 3 out of 9, that's 0.3 repeating. So approximately 33%. Now we need to look at the other condition that they talked about. And that's a person with blonde hair has brown eyes. So which one is given? It's given that they have blonde hair. So I just, again, wrote a title so that I know what I'm talking about. We're talking about blonde hair, brown eyes. So which was given? The person has blonde hair, with blonde hair. So I'm looking up at the blonde hair column, which I don't have highlighted right now. Okay, so with the condition of blonde hair, we're looking at the purple highlighted part that I just have highlighted now. So the total is 7. And of those people, we were looking for them to have brown eyes. So brown eyes would be 2 out of the 7. So the fraction is 2 over 7. So I just wrote that fraction, 2 over 7, which when we put that in our calculator, we get a long decimal of 0.2857142,957. So that's approximately 29% when we round. So now I have the math to support, but I didn't answer the question. Which is more likely? Is it that a person with black hair has blue eyes or a person with blonde hair has brown eyes? So since the 33% is higher than the 29%, my answer is that it is more likely that a person with black hair will have blue eyes. So I just typed that out so you know exactly what the answer is. We were looking for which one was more likely. So when you use conditional marginal frequencies, you just always have to think about the most important and most difficult part is figuring out which one is given so that I know the total that I need to use. Okay, thank you for watching. Have a good night.